Yay. All right. Yeah, so again, create a folder on your desktop. And then once you've done that and you've opened Eagle, let me know. Your screen should look like this. If anyone's having problems, let me know and we'll address that probably in a breakout. But you should see Eagle. You should see these things here. You should see all their advertisements in front of you. Once you've done that, create a folder, go to Options, Directories, and then Projects, and go Browse, and then select your folder that you want to save your stuff into. And then once you've done that, you should see under Projects your new folder. And if you right-click on that folder and go New Project, you get a project in there. So we'll call it PCB. And you should see your project there. So once you have a project, there's nothing in it, it just exists. You can right-click on it again, go to New Schematic. All PCB design starts with a schematic. So you have to basically draw all of your electrical circuits in a human readable format. Then once you've done that, it will basically translate it to a PCB. And that's when we lay out the board. And yeah. So with the schematic and Eagle, basically you'll have this window here. You can switch between your schematic and your PCB by just clicking the board button up here. It's going to ask you to create one from schematics, so just hit yes. And you'll see a board. We're not going to work with the board just quite yet, but you'll see it here. I'm just going to leave it open. You want to leave your board open because Eagle does something called forward back annotation. So if you go, just call this. So you see it says forward back annotation has been severed. So anytime you add something to the schematic in Eagle, it instantaneously adds it to the board. So you can work back and forth very quickly, unlike some other PCB design software. It doesn't let you do that. So you just want the board and the schematic open at the same time. So a couple things about the schematic layout here. These are sort of all of your regular file commands. These are scripts that you can run. We might get into those. I've used them a bit for sort of standardizing my schematic, making it look nice, generating bills of materials, those sorts of things. Down here, this is all, this is SPICE or simulation related. We won't use that yet. I've never used it in Eagle, but here are your layers. So in schematic, you'll also have layers. Really the only ones that you'll use are pins, symbols, nets, names, values, and info. Don't try and remember those. You'll see what they are as we start to draw things. Layers are much more important in PCBs. And you'll see
Quinn, do you have a question?
Yeah, I don't know if it's just like a difference in versions, but my schematic page looks a lot more complicated on the left side than yours.
Yeah, so I think, does it say design manager? And like selection filter and a bunch of other stuff, Quinn?
I have like project documents. Yeah. Oh yeah, everything you said, yeah.
Yeah, okay. That's fine. I think that's just like a different.
Oh, you're seeing this?
Yeah.
Or this?
Yeah.
Yeah.
Okay, yeah, you'll use these eventually. We're not going to worry about them now. I just like to stay on the sheets. Or the inspector. You actually use the inspector most. So you can enable all those views here. All right, I also like do I use a grid in schematics? I honestly can't remember.
So Talal, my guess is just your is just like the size of your of like your screen is probably just causing it to zoom in a bunch. Like there's not a whole lot you can do about like UI elements. You can
drag them away. Yeah.
Yeah.
Also, are these toolbars getting in the way? Is that the issue? Yeah, I have no idea. I haven't had that problem. All right, yeah. I think Carrie can help you out with that. If we need to, we'll go to a breakout room. But all right. So over here, you just have your regular movement commands: copy, paste, trash. This is where you add components. This is where you route nets. So a net is basically a connection between two pins, and a pin is essentially just a connection to some sort of circuit component. Then here are names and values. So generally a name describes what the part is. So like R1 means your resistor number 1, C1 would be capacitor number 1, L1 would be inductor number 1, and so on and so forth. There are a bunch of different ones like U, there's I, there's AC, there's a ton of them, and you'll sort of run across them and understand what they mean later on. There's just other tools down here, line drawing, and then ERC we'll do sort of at the end. ERC is an electrical rule check, and it just makes sure that all of your connections are sort of following the rules laid forth by parts. So just to get started, we'll add a part. So you go here. Well, that is not, those are formerly part. Oh yeah, add part. So it's just this button here. You'll get a pop-up window. I have quite a few libraries in here, but you should see all the ones that say Eagle PCB. If you don't, let me know. But you should see all like Eagle PCB, so on. All right, so what we'll start with, something we learned about before, which is an LED. So there are a ton of them, so we'll try and narrow it down. Chip LED, one word, chip LED. Here we go. So it's just the LED library, LED, and there's a bunch of them here. We want the 0805 chip LED right here. So 0805 is the package size of the LED. It's 0.8 millimeters by 0.5 millimeters. That seems too small. I can't remember, but it's a standard size that's not too hard to hand solder. So we'll go ahead, and once you have that selected, you'll hit OK, and you'll sort of have it around in your mouse like this.
Wait, Ben, I'm not seeing chip LED.
You have to search it all one word. Chip LED, and then the little arrow next to LED. I'll go back and do it again. So remember, add part,
okay.
chip LED. Under the LED, and then LED, chip LED underscore 0805.
Yep, found it.
Yeah, all right. So this is not the actual component that you'll buy. No such thing actually exists. You'll have to go into DigiKey and select the specific LED that you want. We will worry about that in just a moment here. So once you've placed that LED, so you just sort of double click on it, and you can right click to rotate it. And I don't think there are any other, like, there are a couple other weird manipulation things you can do, but rotating is generally all that you will do. So now that I've placed an LED, well, I'm going to need some sort of voltage source to power the LED. So we go ahead and add part. And there's a couple ways we can do this. Let's see if we have USB ports available to us. This is definitely a library that I've downloaded.
Yes. Yep. What's the library name? Because if you look right on there, there's Open Library Manager.
Let's see. USB. Yeah, here we go.
Oh,
so Cypress Industries will have some connectors. We were going to use well, our Arduinos have a mini USB, so we should probably use a mini USB. So you should see con_Cypress Industries after you've searched USB. And under mini USB, we want either one of these. I think that they have the exact same footprint, so it doesn't matter. You can place either one. Hit OK. And so we get a USB port here, and you can just place that here. All right. So, yeah, question?
Yeah. So what's the library we have to download in order?
You don't have to download anything.
Oh, okay.
So you just add part and search USB, and it should be under con-Cypress Industries. Yeah. So it's right here. And then, so once we have the USB, I'm guessing everyone has it. If you don't, let me know. You can go over how to make sure you get it. All right. Yeah, so once we have the USB, we'll just place it. And I don't remember what any of these pins are, so what we're going to do is just go to the browser and we go to mini USB pinout and or Bing. And you know, you can trust the first result. Sometimes it's always a good idea to go to like an actual website. And here we are. So what we know is that pin 1 is power, pin 2 is data minus, data plus, pin 4 is ID, we don't need that, and pin 5 is ground. So what we'll do, we know that 1 is VCC and 4 or 5 is ground. So we'll go ahead and go add part, search ground, and we'll use the supply 1 symbol ground here. You can use the Eagle freaks out if you use the spice one, so just use the supply 1 ground, GND. It looks like it's the upside down T. And you'll just hit OK.
We only have the spice one.
No, you just have to search GND instead of ground.
Oh, okay.
Yeah.
I made that mistake my first time.
Yeah. GND means ground, short for ground. So we just want this upside down T, and we will place that sort of just over to the side of the USB connector. All right.
So grid in the background, that went away from me too, and I don't know why that happened.
The grid?
Yeah, well, I mean,
Yep.
I'm not seeing a grid.
Yeah, to get the grid, you have to go up to the grid button and hit display on and hit OK.
Ah.
Yep. All right. So once you've got the ground symbol, what we're going to do is come over here and click the sort of sideways green L and hover over it. It says net. And we're going to draw a net between the ground pin, so pin 5 on our USB. So you want to click all the way on the left where it lights up with this green circle. And you'll want to connect that to the ground. Now, Eagle will like to draw whatever it thinks is the shortest net, but what I've found and what will matter as you do more PCB design is that your schematic should look neat and readable. So, you know, this is all right, but I don't think that's very neat. So I'm gonna go over and down, and that looks nice. So now we know that pin 5 of the mini USB connector is connected to ground. Now, ground is not a real thing, doesn't exist. So we have to basically connect it to the other side of the circuit. To do that, we will connect our LED. So an LED is not just a resistor, it's going to drop some voltage across it. So let's find an example of an LED. So if we go to digikey.com. We tend to use DigiKey and Mauser are the two big ones for electronics components. And we can just search 0805 LED. And we'll go LED indication discrete. Discrete just means it's not smart. I don't know exactly what it means. Someone else can tell me. And then to narrow things down in DigiKey, you'll get better at this eventually. It's a terrible site, but you basically hit active, in stock, quantity 1 because you're not buying in bulk.
Oh, that is so useful to see the quantity 1.
Yeah, and then you go to, then what else we
Oh,
want is the supplier device package 0805. You can also select multiple because they are the same. All of these are the same. Apply all. All right, so let's say we want this 0805 green LED. Oh, the green one went away. Here it is, green LED from Worth Electronic. So we'll just click on it and we'll go and click on the data sheet. And once we have the data sheet, it's going to download over here. You guys don't have to do this, just doing it for demonstration. PCB design is mostly reading data sheets, so we'll have to get good at that. We'll go over some of the key things here, but it's downloading very slowly for some reason.
Also, you'll notice that these things are stupid. Like, these are so cheap per component. Like, this is 18 cents, and that's probably that's like a more expensive component.
Yeah. Yeah, yeah, for like discrete stuff like this and passive components, they are very cheap. All right, so what we got here is our data sheet. A lot of this information you can actually just find here on DigiKey. So if you're doing very quick design and you know what you're doing, sort of thing, you can just like look. This has a forward voltage of 2 volts, 20 milliamp power, right? So what we see here on the data sheet is the same thing. Most of this stuff is not important. We don't care about it. The only thing we do care about now is the forward voltage. So that is 2 volts forward voltage. And so we want to find the, so it looks like the recommended forward current is in fact 20 milliamps. So we know we have a forward voltage of 2 volts, and we want 20 milliamps. Well, then we'll go to paint. We'll go V equals I R. We know we have 5 volts from the USB. So USB gives you 5 volts, just like the Arduino. We're going to subtract the 2 volts that we drop over the LED. And we're going to multiply that by our current, which is 0.020 amperes. So this is volts. This is amps. And then we're going to get some resistance R in ohms. Pardon the terrible writing here. So this is milliamps, which equals 1 amp times 10 to the minus 3. So there's milli, which is 10 to the minus 3. There's micro, which is normally written as a mu, but that is actually in electronics written as a U, and that is 10 to the minus 6. So we'll use that when we get to capacitors a lot. So going back here, we know that, so 3 volts equals 0.02 R. So if someone does the math here, should be like 600 ohms, right?
It's 150.
Oh, wait, yeah, you're right. Wait, no, it's
Yep, 150.
3 divided by 0.02. Okay. 150 ohms. Well, now we know. All right. So going back to Eagle, We know we need a 150 ohm resistor, so we'll do the same thing as the LED. We'll go back here, add part. We will go to resistor. There's a lot of them here. There are two symbols for the resistor. There's the European symbol and the American symbol. The latter is more what you're used to probably. So we'll go under the RCL library from Eagle PCB. And then we'll go to the R-US underscore under that. And then we'll go to the 0805. So there's two here. So the 0805 and the 0805W are slightly different. We're going to use just the 0805. So that should say R-US underscore R0805, and we'll go ahead and place that, and we'll place it right next to the LED in front of it. All right, so we have R1, we have an LED. Now we know that this resistor needs to be 150 ohms. So we'll go here and click on the value button on Eagle. So it's one that says 10K on it. And then once we click the value button, we'll go and click on the resistor, and we'll type in 150, just like that. So now we've placed our resistor, our LED, and our micro USB, and now we have all the components we need to light up the LED. So what we'll do is we will just very organized here. I'm going to rotate everything. So if you go here and hit the move button, which is like the cross with arrows, I'm going to move the resistor over here and flip the LED around. Now an LED is polarized. So you remember when we were, which resistor was it? Okay, it's so if you go to the add part button, what's wrong? Add part, and we search resistor, you see the RCL, and then under R-US, we'll scroll down until we find R-US underscore R0805. Looks like this.
It's also the one with the highest popularity.
Yes, oh yeah, that's true. Wait, can I not see it? Yeah, there we go. This is very helpful when you don't know what you're doing. This is how I learned which components to pick. The popularity over here is very useful. So you'll see that almost no one uses this part, and everyone uses this one. Yeah, so did you find that all right, Jose?
Yeah, he said thanks, so I think he got it.
Okay, cool. All right. So you should have an LED and a resistor. Now the LED, so the cathode of a polarized part is indicated by a line. So the same thing with a diode, just a regular diode. And the anode is the positive side. That's not indicated by a line. You can also tell by the arrow that conventional current is going to flow on this here. We're going from right to left. So we're going to connect our 5 volts to our resistor, then our resistor to our LED, and then our LED, you're going to go back. And if you want to add a part that you used recently, there's this tiny arrow next to the add part. You can just click that, click ground, and you have ground. So you just hit yes because you want to rename that net. And there you go, you have a full circuit that will light up an LED. Any questions? Did everybody get there?
How did you get the ground? How did you get the second ground again?
Yep, so you're just going to go, you can either go back to add part and search DND again, or you can go and click this little tiny arrow next to the add part, and it shows up on this drop down menu, and you can add it.
Mine didn't come up with a prompt to merge nets, but they both say ground on them.
Oh,
that's
perfect.
okay, right?
Yep. Sometimes it does that. If you connect the net after you place the part, then it doesn't care.
Wait, and how do we put the resistance on the
Resistor? Yeah, so once you place the resistor, you'll see this value button over here. So it's the one that has 10K in bold. And you can just click that, then click your part, and then type the value.
All right, thank you.
Yep. So, and for an ohm, you don't have to type the unit. But you never have to type the unit for any component, because the unit is given by what the component is. So this is resistor, we know it's ohms. All right. So now we have all of our components. We're going to put this on a board. We'll come back to this because there'd be no reason to make a board this simple. You can do this on a breadboard, right? You don't make a PCB for something that you can do, that you can accomplish the same way with a breadboard. Unless, I don't know, there are many reasons why you might, but generally we use PCBs for things that are more permanent or more complicated than something you could do on a breadboard. So, but this is an important, just going over the basics here. So we'll just go ahead and click board once we've done our schematic. And if you zoom out, you'll see all of your components. Now you can move them around. So here is your mini USB, here's your LED, and here's your resistor. You'll notice that they're all connected by these yellow lines. And those yellow lines represent those same green lines that you drew in the schematic. So now, if we look at a picture of a PCB, oh, that's PCB way. So if we look at a picture of an unpopulated PCB, meaning there are no components on it, you'll see all of these like silver patches. Those are exposed copper. They've coated them with tin or something like that, but all of that exposed silver you're seeing is the same as this red that you're seeing here. So those are sections of exposed copper. Now, anything in white is something that your manufacturer is going to print on your board in silkscreen. So all of this text that you see here, that's what you're seeing in the white. The other layers, or the other colors you see here, probably won't show up on the board.
Which screen, Molly? The board one? If you're asking about that, there's the button for switching to board. Yes, I think Ben's on it right now. It's SCH with a green BRD underneath of it.
Yeah. So you'll see these components here. We're going to look at the layers on the PCB now. So if you go to View Layer Settings, you can see all of your layers here. We'll go over all of them, but the standard PCBs nowadays are 2 layers. You have 1 layer of copper on the top, and you have 1 layer of copper on the bottom. In between is what's called the substrate. It is made of generally fiberglass. So those 2 layers, top and bottom, are given by red and blue. These 2 layers, pads, kind of important when you do through-hole components. You'll see those. The vias are connections between the top side of the board and the bottom side of the board. Unrouted are these nets that you see, these yellow lines. So again, those won't show up on your PCB. T names is the silk screen that delineates the names of the components. So anything that says R1, LED1, that's going to be under T names. If you were to flip those to the other side, they would be under B names. So they're on the bottom side of the board. And then you have T values, which is going to be this 150 here as T values. And then B values would be that 150 if you were to flip it over to the other side of the board. We'll skip the other layers for now. So let's say we wanted to flip this other component to the other side of the board. It's space, nope, forget how to do it. In Eagle, I'm so used to Altium. Yeah. No. Yes, it's middle mouse button. So if you have a middle mouse button, click that and that will flip layers. If you don't have a middle mouse button, then you want to go here to this mirror. It looks like two triangles, and you'll just click on the component and it will turn it blue. Then notice that it'll flip it around too because, well, it's a mirror image. It's just on the back side of the board. So I'm going to leave this on the top for now. Now, this yellow outline that we see here is the, oh, someone have a question? Alright.
Emma, your mic is on, I think.
That's fine. All right. So this yellow line is the outline of our board. Right now it's way too big for these three components, so we need to make it smaller. So what we'll do is we'll go and select the dimension layer. So we can, once we've selected the dimension layer, we can actually edit this rectangle. We're also going to go to the grid and re-enable the grid. So we're going to use 50 mil. Mil means 1/1000th of an inch. It's a unit you'll only see in PCB design, pretty much. I've never seen it anywhere else, maybe in like old machinist things, but we'll set it to 50 mil. Looks like there's a question. All right, nope, we're good. So once you've done that, you've turned on your grid, you've enabled the dimension layer. We're going to go ahead and click the move button again, and we're going to drag this down to probably, I don't know. Let's see, that's too small. Let's see, so we can see where my cursor is. We're at 0.75 of an inch, so 3/4 of an inch seems about right. And then we'll go ahead and drag this side over as well. And we'll make this one 1 inch. You can also edit these numerically. So if you just click the I button, I means info. You click I, you can then click on the line, and then it will give you all the numbers. So you can see that this line is not actually on anything. So we'll go to 1,000. Oh, 1,000. We'll go to this one, and we'll make it 750, and then 750. So now our board is exactly 3/4 of an inch by 1 inch. All right. So once we've made our board to size, we will go and drag our USB connector over onto the board. Not going to worry about centering it now. Generally, the first step in PCB design is to get your board shape how you want it. If you're doing it professionally, someone else would probably give you the board shape. Oh, question. Where was the I button? The I button is up in the top left. Looks like a lowercase I in a circle. Yep, so generally the first step is getting your board shape. If you're doing it professionally, your mechanical engineer will give you your board shape, and then you have to make everything fit on it. But in our case, we're doing all the steps, so we'll define our board shape however we like. Once we've done that, the next step is placing your components. So generally, what I like to do when I'm placing components is I do what I call like a,
Ben, I think I missed it, and there might have been a couple other people who did too. So just getting the board dimensions right.
yeah.
How do you edit the? Oh, you have to go to layer dimension.
Yes, you have to click the dimension you're working on. Otherwise, Eagle won't let you change anything about that layer.
And then how do you set it to mils? I probably just missed this, but
to set the grid, enable the grid.
Ah, there we go.
Yes, you click the grid button and then display on for 50 mil. Don't use millimeters. Most everything in PCBs is done with imperial units, even in like other countries. So, yeah. So generally, I do like a rough component placement. So I'll sort of just get the components where I kind of want them on the board. In this case, kind of want my LED right in the middle, so I'm going to do that. And then once I've sort of placed them where I kind of think I want them, I'm going to place them exactly where I want them. Which LED was it? Are we back on the schematic? Hello? Come back to that in a second. Yeah, so I generally do a rough placement of the components, so I get them where I want, something like this. And then I'll do a final placement. So with a final placement, I'm probably going to want to center everything. So again, I'll use the I button. And I know that the center of the board is 375. That centered my connector in the y-axis. Do the same with the LED. So 375. Now both of those are centered. And then the next thing I'll do is move this connector over, because in order to properly connect to a micro USB connector, it needs to be over the edge of the board. Which button? Oh, the dimensions don't matter, Molly. You can do whatever you want. I've done 3/4 of an inch by 1 inch, so you can see those dimensions up here. And which button are you talking about, Emma? Oh, and please feel free, everyone, to just, you don't have to send anything in the chat. You can just interrupt. That's totally fine.
The I button where I'm supposed to
Yeah, so you have to click the I button, and then you have to click what you want to look at.
Oh, okay. Got it.
Yeah. The other way you can do it is use the select tool, select what you want, click the I button, and then it will show you.
Which one's the select tool?
The select is the group button. It looks like a dotted rectangle with a pointer. So you click what you want, and then click the I button, and then it will show you the
Still not
details. So you've clicked the I button. Are you in the dimension layer?
Yes.
And then you click that top line as close as you can get.
Oh,
push
I
into it.
may be missing the line. Yeah, I missed the line.
All right. All right. Yeah, so I've done a sort of a rough placement here, and I'm just moving everything exactly where I want it. So I'm going to move this connector over the edge. It's a little too far. So back. Oops. All right, perfect. Yeah, so I've done this just a little bit over the edge so that, like, I don't know if you noticed, but when I move something too close to the edge, it lit up with these cross-hatched like warning areas. That means you've broken one of the design rules. The design rules basically tell you what you can and cannot do, because only certain things are actually manufacturable. All right. So now that I've placed the LED where I want it in the center, I've placed the connector where I want it in the center. I'm actually going to put the resistor on the back side of the board because I don't want to see it. It's ugly. So I'm just going to put it.
Wait, which button did you use to flip the side that it was on?
Yeah, so you can use the middle mouse button, or you can also use this mirror button over here on the left side. It looks like 2 triangles, and you just click the part.
And then also, I noticed when you put it to the other side of the board, you're also going to need to right-click to rotate it twice, because otherwise your wires are crossed and it looks weird and probably would be bad.
You don't want your wires crossing, so the way you can tell, sometimes it's hard to tell if it's done like this. I can't immediately tell that my wires are crossed, so I'll just drag it away, see that it's crossed, and then flip it around and drag it back. So, just a quick trick. All right. So now that we have that there, I'm going to delete the things that I don't want, which is this ugly mess of text here. I'm just going to delete that using the delete tool. So now we don't see that anymore. I'm also going to delete the value of the resistor. We don't need to know that. We have a schematic that tells us what that value is, so we don't need it printed on the board. So I'm going to delete that as well.
If you're confused about the delete, I found that you have to make sure you click the little arrow at the corner. Otherwise, it just pings at you and it's really annoying.
Yeah, yeah. There's everything in Eagle. Like, say I want to move this connector, I can't just move it here. I have to click on this little crosshair. Same thing with everything else in the board layout and also in the schematic. It's actually a nice feature. Altium doesn't do that, and sometimes you move things that you don't want to move. So, all right. So now that we've placed everything where we want it, we can go ahead and start connecting our nets. So I'll start with the ground. So what we'll do is click this button that says Route Air Wire. So we go Route Air Wire, and then you'll see up here all of the details on that air wire. So the width is the width of the track. Right now it's 6 mil, which is generally like the minimum that a cheap PCB manufacturer will do. You can go bigger and smaller, but we'll do 8 mil, I think is good. You can also change the wire bend format. I generally use the 45-degree bends. It looks nice. It's kind of what's used in industry. So at that point, we've selected our tool. So our root air wire tool, we've changed our width to 8 mil up here. And then we'll go ahead and click on the ground of the resistor. And you'll start to see that when I move my mouse around after I've clicked, I'm going to start trying to follow my mouse with a track. This is called a trace. And what I'll do is I'll just drag that trace right over to the other highlighted pin on the USB connector. And click, and it should route that. And it gets rid of that yellow wire that we were seeing, meaning that the connection has been made and it's a good connection. So like if I were to do this and not finish the connection, then it would still show the yellow line to the closest point. So I'm just going to draw that again over here, like that. So it goes right into the middle of the pin. Just looks nice. Did anybody have trouble with that? Any questions there?
How do you get to the wire again?
Yeah, it's the root air wire button over here. It looks like a blue squiggly line with 2 green dots.
Got it.
And then you'll just click a component and it will start following you. Then you click the next highlighted pin, which is over here on the connector. So we've routed the ground. All right, once we've done that, we want to route our 5 volts to our resistor and then to our LED. Now, if we just go to the regular air wire, we are on the top layer and we can't get to this resistor to finish that connection. So what we need to do is use a via. Now, a via can be done, a via is essentially a hole in the board that has been plated with metal, and it connects the connection from the top layer to the bottom layer. So what I'll do is I'll just start that trace, go where I want to place the via, press the space bar, and then I can continue dragging out. My color will change to blue, and I can make that connection to the resistor. Same thing on the other side of the resistor. Are there any problems there? Everybody get the via all right? Yep. So once you've done
How
that,
did you connect it to the resistor?
so did your color change to blue?
No, I think that missed the previous step.
All right. So when you have the route air wire tool and you click on this pin here, you can sort of drag a red line around. Is that true?
Yeah.
All right. So what you want to do is just hover your mouse where you want to place a via, press the space bar, you'll see a green circle show up. Then you click again to place that green circle. And then you should have a blue line that you're dragging around.
Oh, I think my resistor is just not upside down.
Is your resistor red or blue?
Okay, now it's blue, but my via is still not.
Oh, Molly, I just saw you asked a question. Are you still having issues?
I figured that out.
Okay, cool.
But I didn't get the ground all the way with so that might be the problem.
It shouldn't matter, like if you haven't completed a net for something else, Eagle won't care if you go on to work on another net. So
Does dimension matter here? Or layer?
you want to be on the top layer,
Oh, I'm on the top.
and then you click the air wire button, root air wire.
Yeah.
And then you click what you want to connect it to. You should have a red line. Then you click spacebar, and you see the green circle.
Yeah, I just can't get the circle to be blue.
The circle shouldn't turn blue. The
Or
circle should stay green.
So then once the green circle, if you click, what happens?
Yeah. If you click the green circle, then you get a blue line.
One sec.
So I'm doing the same thing for the next pin for those of you following along. I'll just connect the other side of the resistor. Did you get that, Emma?
Not yet. I'm gonna undo a bunch of stuff from me messing with it.
All right. Any questions here from anyone else? Did everybody have this point? They should see you should see no more of those yellow lines connecting your components. All right, cool. So that is a completed board. You could in fact order this and someone would make it for you. It would cost $5, 17 bucks for shipping, and you'd have it in 2 weeks. So.
And
We're
that
not
is
gonna-
about the same exact price we paid for all of your Arduino boards.
Yeah, they're not expensive. It's great because we can basically make whatever you want, order it, and you don't really have to worry about spending too much money except on components. Like when you get to the boards for Redshift, our components sometimes are $25 a piece, so we can't really screw up. We'll take them off old boards when we make new ones. But yeah, these components here probably would cost about $1 for everything, so that would be pretty cool. So this would plug into your computer and light up an LED. We can see this in 3D, and maybe I'll try and show that. I'll just do that quickly while we're waiting here.
Okay, yeah, I don't have Fusion installed, so I'll let you do it.
Yeah, I'll do that. Don't bother with this. I'll just show you guys what it looks like, unless you have Fusion 360 installed. I'm just going to hide that. All right, so here's our board. We'll go back to our schematic. And we're just going to go through and check and make sure everything's right. So we'll just go to the schematic. We see our components here. I'm going to click ERC. So should say part LED1 has no value. Well, that doesn't matter because it's just an LED. An LED doesn't have like a capacitance, or I mean, it does. It's not a perfect component, but it's not something you describe with some value. So I'm just going to hit approve. That's going to hide it, and it won't matter. So there's no other errors or warnings. That means our electrical schematic it's not necessarily correct, but it is not wrong in the eyes of Eagle. So you could have something connected totally wrong, and Eagle's not going to tell you. something you'll find later on. But in this case, there are no problems that are breaking Eagle's rules. So we'll just hit X, and then we'll go back to our board, and we will click down here, DRC. So DRC is the same as ERC, so electrical rules check, except for your board. It's the design rules check. So if you see here, we'll go to all of these tabs are different rules that Eagle defines.
Ben, we can't see the
And-
tabs. Oh wait, nope, they showed up now. Okay.
So, someone have a question?
Nope, you're all good. Can you hear me, Ben? Or is my no, my mic's working.
Oh, we can hear you. I don't
Is my
know. If
internet bad?
Ben's... Oh, there you go. Hi.
I think Ben's dropping. No. No.
What? I'm back.
Oh yeah, no. Your screen was just lagging behind what you were saying, and I said that, and then I think you just disappeared.
Yeah, my internet just died. I don't know what happened. Let me share screen again. Share. All right, yeah, so did everybody hear the thing about the DRC button?
If you don't
Let's
see
say
it
it
on
again.
your screen, there might be a little arrow at the bottom of your, like, the thing with the root air wire and the, like, I info. At the very bottom of that, there's a couple little arrows.
Yeah.
If you click on that, you'll see DRC under there.
Yeah, you can also go to Tools DRC. Yep. So all of these tabs here are different rules that Eagle defines, and you can change these rules because a different manufacturer may have different rules. So if, just for an example, if we go to jlcpcb.com, which is generally what we use because they're very cheap, we'll see that, where are we going? We'll go to the capabilities tab. This is where most people list their thing. And we will go to minimum clearance. So this is normally the one that most people care about. So all of these are about the same. So 0.254 millimeters. We just go 0.2254 millimeters, 2 inches. Oh. That's 4/1000ths of an inch. Or what? No. I hate Google.
40 thou.
0.2. Sorry, 10,000ths. That's terrible. Oh, here we go. Yeah, this is what we care about. These ones don't matter. They sort of do, but not really. This is the one that we care about. 5 mil. So on an outer layer of a 2-layer board, our traces can be no closer than 5 mils apart. Or actually over here, that's the spacing. The width is the width of the trace. So our trace can be no narrower than 5 mil. So let's say the correct way to do this is before you even start designing your board, you go to your manufacturer and you go through all of their capabilities and you enter all of those numbers into your rules. Some manufacturers will provide a rule set that you can just upload. Others you have to do it manually. So we'll just go here and we'll go wire to wire is 5 mil, right? And all the other ones will leave at 6 mil because they're actually greater, but we won't go through that specific stuff now. Then we'll go to sizes, the sizes tab, and we can change our minimum width to 5 mil as well. And I'll hit. And so now our minimum trace width is 5 mil. So I'm just going to hit apply, and then I'm going to hit check. And what check is going to do is check my board for errors. And you'll see that my board has no errors. So it says that down in here in the bottom left. So the board has no errors. Now, if my board did have an error, so let's say I routed a trace that was 4 mil. Oh, let me unroute this. So I'm going to route a trace that's 4 mil in width. And then I go and run DRC again. So I'll go check. All right, DRC.
I think that was 5.
Oh, that's why. Yeah, because it won't let you do. Yeah. It actually won't even let you do it. But you can essentially, you can cheat the system and just go here and go width equals 4, right? And equals great because it's just going to light up things that are wrong in red, right? You'll see that from a mile away, like this is not right, because it has this sort of cross-hatched.
And wouldn't red be a bad color to have light up as a warning?
No, it's like a different red. I don't know if you can tell. Like it's standing out much more than the other reds. But yeah, I suppose you can change all the colors. It's personal preference, but this is what I use. So I'll just go DRC again. And I'll hit check. And it's going to say 1 error. So what we do, we go under errors, width, and it's going to highlight the problem here, right? So I'm going to X out of that. I'm going to go fix my problem. So I'm going to go here, info, change that width back to 5. Then if I go DRC again, check, I should have no errors. So if you did everything right, your DRC should say no errors. Did everybody follow that? Any questions?
I have a general question from before.
Yep.
How do you get your USB to hang off the edge of the dimensions without the others, like the M1 and M2, being too close to the edge?
Yeah. All right. So what you want to do is, so there's 2 ways of doing this. You can either use the I tool, so the info tool, click on the little yellow crosshair on your USB connector, and you can change the position at any increment of your liking here. So I did 5 mil there. So that moved my part like that. You can also go here, go to your grid, and make your grid smaller. So I'm going to make my grid 10 mil. And now that my grid is 10 mil, I can drag this part much more finely. So I'll get it as close as I can without my error symbols lighting up. So you can see the error boxes lighting up. So just put it as close as possible and leave that there. I'm going to recommend that, well, when you're laying out a PCB, you want to keep the grid size as large as possible for as long as possible. Because what happens when you make the grid too small too soon is your parts end up sort of all over the place and there's no sort of regularity or grid pattern to your board. And it's really hard to go back and like fix all of those dimensions. So I like to just sort of keep this at about a grid size of about 50 when I'm laying out parts for the first time. So.
Okay, thank you.
Yep. Any other questions here?
I had a problem with getting the resistor and LED like onto the board part of it, because whenever I try to move them on, it says there's an error and it says the free edition can't do this when I try to move them onto the board.
Yeah, so I was having that error. Make sure that you click the little like cross-looking move thing, and then make sure you click the little yellow crosshair in the middle of the part.
I don't see a yellow. Oh, yes. Okay.
You can also get around stupid errors like that by just logging in with your school account. And that will give you the full version of the software.
That's what I did, but it still says I'm on free.
Oh, then you have to go to Autodesk website and basically verify that you're a student. There's some process, and I forget how it works. Normally just a .edu works, but I'm not sure.
It all depends on how much the company cares, because like
Yeah,
you keep your .edu after you graduate. So
for SolidWorks, I had to prove I was a student here by like showing like some identification thing, and I just put a picture of my Husky ID, and that was fine.
Yeah, I had to get PSpice for a project, and I had to give Cadence my student ID. So yeah,
okay.
there's some softwares that
getting the license from Cadence is the most annoying thing.
It wasn't that bad, actually. Actually,
Oh, it took me forever.
really? I just emailed them a picture of my Husky ID, and they were like, "Oh, here you go."
Sorry, it took me forever to get it working.
Oh, that's true. Yeah, that software is a nightmare. But that is actually Cadence Allegros is what Apple uses to design all their boards. So, fun fact. OrCAD also contains a lot of the software that professionals use to design integrated circuits. So that piece of software, I imagine, is on the orders of hundreds of thousands of dollars. So this is why learning these softwares now, and when you have an EDU email, is great because it's all free. So employers like that you have experience with things. Even Eagle's great. Like Eagle is used by a lot of companies because it's so simple and it's cheap and it works really well. So, all right. If there are no problems there, let's go back and make this a little bit more complex. If you have to go, I suppose now would be a good time. If you want to stay on, I'll continue this and we'll make our board a little bit more complicated, add a few more components to it to make it do some cool stuff. While we're
Sorry, say that again. What?
so yeah, so we're gonna sort of shift gears here. Let's see, someone sent a message. All right, have a good night. Good luck with your midterm.
People have been leaving before I get a chance to say bye.
But yeah. All right, so yeah, if you're hanging around, we'll spend a little bit longer and we'll make this a bit more complicated. All right. Good night to all.
All right, I shall head off too then. Thank you guys.
See ya. Yeah, for those of you hanging around, we're just gonna add a few more things to this. Answer any more questions that you have. Let me know. Is there anything that anyone really wants to put on this board or make this LED do or something like that? There's some component that you've seen that's interesting.
Oh, Matt unmuted.
555 timer.
You want to do a 555
I mean,
timer?
everyone just keeps talking about it, and I've never actually seen one.
Yeah,
So-
let's do it. Let's do a 555 timer. I've actually never done. I've used them like once or twice. So this will be a learning experience for me. We'll go through the data sheet and everything. So I'm just gonna go back to the schematic. We'll leave this here because it's nice. We can get power for our 555 timer nice easily. When we go back, add part. Hope that Eagle has it.
Don't type 555. If you type timer, there's a linear *55.
General bipolar. Yes, here it is. ST Microelectronics.
That one, or do you want to
55.
do the linear one from Eagle PCB?
I mean, it's the same.
Is it the same? Yeah, it's the same. Yep. So let's use
This
the
one.
ST
All right. So
one.
this one's functional. This one's what? ST. What is going on? I'm going to use the one from linear because it's numerical and I like that.
If you go under
Actually, no,
linear,
it's not.
there's multiple of them.
LM5. Oh my God, there's so many.
Choose the most popular, I guess. I don't know.
Probably, yeah, this one. It's surface mount. So if you guys wanted to make this board, it'll be a little bit harder to solder. But let's go surface mount. That's sort of the next step. You guys already did through hole. So we're searching timer. We're going to linear, and then we're going to NE555D. And it's an SOT8 package, or SO08, something, I don't know. And I'll just hit OK. And now I have a 555 timer. Now I don't know how this works, so let's go to the data sheet and figure it out. So DigiKey. And we'll search the same exact part here on DigiKey. It's the NE555D. And this one is from ST Microelectronics. They're all exactly the same chip. But then we'll go to data sheets. We're going to download the data sheet for this chip, which doesn't exist. So we're going to go back and we're going to select the one that is still made. That doesn't have a data sheet. Go to the one from TI. Get the data sheet. There we go.
TI components always have nice data sheets.
Yes, some of them. So there's a couple weird things. Like sometimes it's clear that they've thrown the data sheet at the intern. It's not very good, but generally TI makes very good data sheets. So, all right. So I always like to read the description of the chip that I'm working with. So I'm just going to do that quickly. You're welcome to read along. I'll zoom in here. All right, interesting. Didn't understand any of that, but we'll continue. It's generally how most of it goes. This is the simplified schematic here. So we have a some sort of.
So that is a flip-flop. So that's a memory device.
All right, that's a flip-flop. These are buffers. This is a buffer. This is a buffer, I think, or an amp. I don't know. This is a transistor. All right, continuing on. We don't care about any of these. Circuit for monostable operation. So monostable operation is initiated when all right. So I'm looking for some equations. All right, so time high. All right, this is what we're going to use. This is the circuit we're going to use here. So we're going to need to do some math. So these equations describe the time that the circuit is high and the time that the circuit is low. So we're going to have a hard time finding capacitors that are big enough to make our time go up. What unit is this time in? Is this seconds? Must be, yeah.
Because you're doing R and C, yeah.
Yeah, so let's say, well, we're going to need some pretty big numbers here. So like a standard, like pretty large capacitor size is going to be 22 microfarads. So we'll go 22 times 10 to the minus 6 times a pretty standard resistor size of 100,000 ohms. So 100K is what they call it, times 0.693. And this will give us a low time of 1.5 seconds. So we can then use say a 10K resistor on RB, and that will give us just a bit longer than 5 seconds, or 1.5 seconds. All right, so that's what we're going to use. So I'm just going to draw it out so I don't forget. So we know that RA is 100K ohms, RB is 10K ohms, C is 22 microfarads. So 22U. Now we got to draw this circuit. We also need to find out what RL is. What's RL? All right, we'll come back to
if
that.
you look in that schematic right there, it's using a 1 kilo ohm load RL.
All right, we'll copy that. RL is 1K. RL equals 1K. Most things I do like this is just copying the reference design. So, all right, so we'll go back to our drawing. I'm just going to put these side by side so that we can reference them easily. All right. So great. So we're going to need 3 resistors and 2 capacitors. So what I'll do is just go back here. I've already added the resistors. So I'm just going to place 3 resistors. Then I will go and find myself a capacitor. So we'll go add part. We'll search cap capacitor. Yep, you have to search capacitor. And then I'm going to go to RCL, which is Eagle PCB. I would go to CEU because I like the euro symbol for the capacitor better. And then I will use the most popular one, which is the 0805 capacitor. And I will place that. Then I will place another. So I have 2 capacitors and 3 resistors. Did everybody get that?
Which capacitor is it again?
All right, what did you say, Molly?
Which capacitor is it again?
Yep, so we'll go add part. I'm going to search capacitor. And then under RCL, which is the Eagle PCB library for capacitors, I see CEU, C-EU. I'm going to scroll down until I find C-EU C0805.
Thank you.
Yep. Someone else had a question? All right, so we have 3 resistors, 2 capacitors, and now I'm just going to use my reference schematic to connect everything up. So what I will do is I see that threshold and trigger are connected. So 2 and 6 are connected. Of course, this is a terrible design. So I'm just going to draw a line around from threshold to trigger. And then I know those are connected. And then I'm going to take one of my capacitors. I'm going to connect that to the bottom of trigger like that, or threshold. So you see here 6 and 2 are connected together, and then there's a capacitor connected to that. Then I'm going to copy and paste my ground symbol over here. Connect that to the bottom of the capacitor. So it looks like this right now. All right. Now I'm going to take another resistor and I'm going to connect that over here to R3, one of my capacitors or resistors. And I'm going to connect the other side of that to my discharge pin. So everywhere you see a dot means there's a connection between 3 or more junctions. So you see that I've drawn this line over this net and they don't make a dot. So that means they're not connected. You can also go here. Google it. Oh. All right, never mind. Eagle does not do that. So we're just going to have to deal with the fact that it's crossing and we can't really tell. All right, so I'm going to take my other resistor. I'm going to connect it to the other side here. So it looks like that. And then, so this is RA that I've just placed. And then I'm going to connect that to the reset pin, which is pin 4, which is all the way over here, unfortunately. So I'm just going to draw that around, connect it there. All right, I'm going to move this over so it looks nice. Move there, never mind. So we now have 2 resistors placed and 1 capacitor placed. And then we need our whatchamacallit over here. So we will connect RL to the output. So that is going from VCC to the output. So I'll do that, draw that here. Oh, this is not good. Terrible. And then, so now our V plus is connected to our Q through R4. So this is RL that we've just placed. And then we want a another connection here. So I'm going to just draw this down. This is our, let's call it power connection. And I'm going to put our C2, which is our decoupling capacitor, over there, connect it to that. This really doesn't look very good, does it? All right. Cool. Yeah, and then I'm going to grab my ground again. So same thing, it's the ground. I'll connect that there, and then I'll connect one over here. And I'll draw those. So I'm going to connect my ground pin to ground. I'm also going to connect this other side of the capacitor ground. Now, I also want to label this net, because this is 5 volts. Like here, you see VCC 5 to 15 volts. So we want to label that net. So I'm going to use the label button, which looks like an AB. I'm just going to rotate it so it's along the line. Info, and call it 5B. All right, this looks pretty terrible. All right. Now we have pin 5, which we need, it says leave open, so we're going to leave that unconnected. I'm just checking that we have all of our other connections made. And so then I'm going to do the same thing over here. I'm going to label this net as our output. Makes sense, hopefully. So we have our 5 volt going to our V plus. We have a resistor going to our Q, which is our output, and then we're labeling that net output. All right, see you, Jen. Have a good night.
Good night as well.
So what I'm going to do now is we're going to put values on all of our outputs here. So we're going to, or on all of our components. So we know that C1 was our oscillating capacitor, which is C, and we guessed that to be 22 microfarads.
Wait,
So,
Ben, I'm
yes.
noticing one thing you might be missing. Pin 8 also has to connect somehow to pin 4.
Oh, you're right. Pin 4 connects to, yeah, you're right. So I can just go, like that. It's so ugly. Oh, I should have used the other schematic symbol.
Is that the right place?
Yeah, it is.
I think it needs to connect
No,
before
you're
R4,
right, you're right,
though.
you're right, you're
Yeah.
right.
It's so ugly.
Maybe we should switch symbols. I feel like this is too late, but I'm gonna try it real quick and just see if it looks nice.
Yeah, the shape of this symbol does make it kind of weird looking.
Yeah, this is what we want. So if we use this symbol, then pin 5 is connected to nothing. The output.
How do you change the text on the labels? So Molly, I had a bit of an issue with
VCC
that.
is connected to
What I
Windows
ended up
Perfect.
doing was if you go to info mode, so the eye with the circle, and then click on the little plus sign next to the text, you'll see like a part, you'll see like a name field, and that's where you can edit it.
I'm switching symbols, if you didn't notice. So if you want to switch symbols, it might help. I searched, I went back and searched timer again, and I went to the ST Microelectronics NE555. This will make things easier to look at.
And a good time, this is a good chance to practice doing this quickly.
Yeah, how do you change the text on the labels? All right, so we'll do that now.
I already. Oh, is there
Okay.
an easier way? Because I went through
I
and
just
used.
label, you click label, then you place it, then you go to name, and you click the net, and then you go 5 volts.
Okay.
Which
that's
timer
easy.
should we use again?
We're going to back to parts, add part, timer, ST Microelectronics NE555.
Okay.
Yep.
Yeah. That should make this a
should
lot
make it
simpler.
way nicer. Yeah. So then I need to remove my R4 over here and connect it between my 5 volts and my output. So that's RL that I've just placed. All right. And then 6, 7, and 2. So again, we're going to join pins 6 and 2. Whoa, no, that stinks. All right. We're going to join pins 6 and 2. Then we're going to move our capacitor over here. We're going to move our ground back over there. All right. And then we need a resistor going from pin 7 to pin 6 and 2. So we'll draw that. We'll go pin 7 to pin 6 and 2. Then we're going to move our other resistor back over here like that. And then it's going to go to our output. And much nicer. So I'll delete this. Bring my decoupling capacitor back over here. And connect that to ground as well. All right, this is what it looks like. I'll leave that there for a minute.
And go get some water. I'll be right back.
You guys all keeping up fairly well? Or the ones who are left?
I have some catch up to do.
I am slowly making my thing not look
Same, it's
like a spaghetti monster.
very fast.
Yeah,
Yeah,
no. Ben
was
goes fast.
Yeah,
It's on like 3 times speed.
So when there was a bunch of people here asking questions, it slowed him down a bunch.
What? Someone
No,
talking about
Ben.
me going too fast?
Yeah, Ben, you got quoted as 3 times speed. I won't say who, but
No, you gotta tell me who. Was it Carrie? It was definitely Carrie.
Carrie's not even here.
Oh. Was it Matt?
No. I
All right, I'll let you remain
Yeah.
anonymous for now. But
don't know. Mine looks different, but I think it's accurate. I checked it against the reference, and it
Yeah.
looks to be the same, but
yeah, that's what basically every time I've had times where I'm not even kidding. I was going to sleep and I had ordered a PCB that night and I woke myself up from sleep because I thought I'd connected a pin wrong. It's so bad. And
Don't worry, Ben. I've done that with code. Like I've woken up in the middle of the night with solved a problem in my head and just been like, okay, guess we're writing code now.
I had to like, oh, it was so bad. Anyways, so that's a fun thing you'll do is finding problems with your designs. It's just like anything, like writing code, except you can't check it instantly. That's the thing. You can't just press run. But yeah. All right, so let's assign all our values. With any questions there, I'll still try and slow down. There's some questions.
Can I get rid of my LED and my old one?
No, we're gonna use that to blink. We're gonna use this to blink the LED.
Oh boy. Okay.
Yeah, so we're gonna save everything there.
How do I get rid of the old spaghetti monster of the chip?
Just use the group tool, and you can just like drag over it, and then press the delete key.
Okay.
Or you can group it. You can group the thing, press the delete button, right click, and delete group. I'm gonna undo that. But yeah. If you want to move groups, the way you do that is you group it, you go to the move tool, you right click, and you move group. So I'm just gonna move it down. All right. So the other thing, next thing we need to do is make our output pin available to our LED. So I'm just gonna draw a line outwards. Oh gosh. I'm gonna label that and call it output. Great. All right. All right. So next thing is to number or give our components the values that we calculated. So C2 is given to us. It's a 0.01 microfarad, also the same as a 10 nanofarad. But you will never be able to find the 10 nanofarad capacitor on DigiKey. They don't exist. You have to search either 10,000 picofarad or 0.01 microfarad. So we're going to call it what we can find, a 0.01 U. So U means micro.
oh, we don't need the F. It's just because it's a capacitor. It's obvious.
Yeah,
resistance.
yeah,
Okay.
exactly. Yeah. Yeah, so there are lots of tricks to like shorten things. You'll even see that when you get into like really, like I had to read schematics from old, like an engineer that was like 60 something or whatever. He just writes 1. if a capacitor says 1 on it, it's a 1 microfarad capacitor. Because you'd never use a 1 farad capacitor. So, all right, so R4 is our load capacitor. I seriously don't know what that's supposed to be, but I'm going to trust Tyler in that it is a 1K.
I mean, if you look up on the diagram they gave, RL equals 1 kilo ohm.
Where does it say that?
To up on that on the output voltage chart above.
Oh, yeah.
So either 1K or scale it based on what your RA and RB are, because our RA and RB are not 3K and 5K.
I feel like it should tell us what it is. RL.
I wrote down 1K, but I don't remember where I got
Yeah,
that number from.
we're gonna put it as 1K.
Okay.
So we'll go here and go to value, and we'll go 1K. So I'm gonna move this around so I can actually read what I've written there. So it says 1K. And then we'll go here to R3, which we calculated as, so this is equivalent to RB. So we calculated RB to be a 10K. And we calculated R2 to be a 100K. So it looks like that. And then we guessed C1 to be 22 microfarads. 22 U. Any questions there? Anyone not understand how we calculated those? I did that pretty quickly. I can explain what they do in a second here as well. But I want to figure it out how they work in my head. All right, yeah, that makes sense. All right, so RA basically determines how quickly, well, RA plus RB determines how quickly you charge the capacitor, right? So that's why this time high, right? Because a capacitor, how quickly a capacitor charges is determined by the size of the capacitor and the resistance that's charging the capacitor, or the resistance through which you're charging it. So we're going to charge it from the high voltage through RA and RB, and we're going to charge it. Once the threshold is reached, so once the capacitor reaches a certain voltage, then a gate opens on the discharge pin. And that discharge pin is going to discharge the capacitor through RB. And it's going to discharge that through the output. I don't know what RL does, still don't. So hopefully that makes sense. We can go over this again.
So I think 'cause there's a transistor on the output, RL is some kind of like, just like a feedback biasing measure, this would be my guess.
Discharge.
No, it's on that buffer.
All right, so threshold. All right, so threshold and doesn't matter. So reset is connected to VCC. S is the trigger.
So the way that works is that's a flip-flop. So you have R1, reset, and set. So when reset is set, the flip-flop goes low. When set is set, the flip-flop goes high. And if reset is set, it goes low, I think.
Wait, so in this case, trigger is always set. Wait, no, it's not. So trigger and threshold are the same, right? Because they're connected. They're pins 6 and 2. Right. So when
So I think it is when the voltage goes over a certain level.
No, because reset. So reset. All right. So here we go. Reset is the reference to which we can. I'm going to call it comparator because this is what I used. This is essentially a comparator at this point. So we have our reset and our R and our S. So when R and S go above half of VCC, which is our reset, then the flip-flop goes high and outputs the buffer thing, and then the thing discharges through this stuff. Oh, wait, no.
Yes. That makes sense. All right. So we open the gate. That opens the gate of the transistor, which discharges it through the transistor and through the output buffer. All right. There we go.
Still not sure I 100% understand, but
Yeah,
I kind of get the idea, right? Like you're charging a capacitor and then it discharges as your LED turns on.
Yeah. It's complicated. Like I don't really understand how this sort of low level electronic stuff works, but it doesn't really matter for a lot of what I do. But all right, moving on. We're going to disconnect our power. So pin 1 on our USB connector. We're going to disconnect that from our resistor. Now I'm going to move this over so it's out of the way. So we're going to go move group. We go here. Move group. All right, so I'm going to move that up there. And I'm going to move this as well because it's ugly. I'm going to move this over here. I'm also going to rotate this so it looks nicer. And then pin 1 is our 5 volts. So again, we're just going to make a line. So we're just going to make a net. And we're going to go here, add a label. I'm going to go name. We'll go 5 volts. So there we go. We've connected pin 1 to 5 volts over here. We've connected ground to ground over here.
How did you disconnect it?
Oh, I used the trash button to delete, and I just clicked on the green line that I wanted to get rid of. All right, so same thing over here. I'm going to rotate this to make it look nice. I'm going to take this. I'm going to move group. Spin it around like that. So I just like making things look nice. It's easier to read when they look nice. So then we're just going to add another line in front of our resistor here. And I'm going to go add another label to that. We'll go name. We're going to name that label output. So that is going to connect this resistor to the output pin of our 555 timer. That's what we have here.
Any questions there?
Not yet. No, I think I've got at the same spot you are.
All right. Give you guys another minute or so. Right. So now we have our schematic. We can go and put this on a PCB. So if everyone's caught up here, we'll go ahead and do that. Please shout if you're not. You can answer questions.
I'm still trying to catch up with all the labeling and stuff.
Oh yeah. Sorry, that's kind of it's all like the little tricks, like how to edit things quickly and whatnot that I picked up and take for granted. So I apologize.
Yeah, this is also really difficult if you're doing it on one monitor or or without a mouse.
Oh gosh, yeah.
I couldn't imagine doing this on a trackpad.
I've had to do SolidWorks on a trackpad too many times.
So I actually have done a little bit of SolidWorks on a trackpad
So bad.
back in Cornerstone.
Yeah.
Oh no.
Well, because I just would forget to bring my mouse to class, and
Can't forget to bring your mouse to class if class is your dorm room.
I know that is very true.
Yeah. I don't know how I feel about having to actually go to campus for class in the spring, but we'll see.
Yeah, I don't know. I mean, I'm on campus. I could go to class if I wanted to, but I have not gone to a single one.
No, there's nothing. Like, I'm on co-op now, so I don't know. Aren't some of the like the in-person classes? Those are some serious air quotes. Aren't they just like projectors with the Zoom call on it?
Oh yeah,
Couple are. Yes.
Yeah,
Not many.
So
Yeah.
the only person I know who's gone to one of those is Shayla. Went to one the first day the class happened, and then never went
gosh.
again. So
Yeah.
if I went, I'd go to the one where the professor is there. But that's also a class that I just don't care about, so I don't think I'm gonna go.
Yeah. Trying to lighten my load for the spring. I don't want to take heat transfer.
How many
And,
credits are you guys taking?
Right now, I'm registered for 19 credits.
17 right now. Right now in the
Okay.
fall.
Okay. Yeah, I'm trying to figure out how much is insane.
I mean, it
Northeastern will
depends.
charge you, if you try to take more than 4 regular classes, Northeastern's going to charge you about $2,000 per class more. They call it,
Interesting.
it's called a what's it called? It's like an overbooking fee, but like an
Overloading?
overload fee. Yeah, that's it.
I mean, it really depends what classes you're taking.
Yeah.
Right.
What are you
Does the
thinking of taking?
overload fee apply to like if you're like 1 or 2 credits over because of labs?
Labs
No,
don't
no.
count towards
Yeah.
it, right?
Yeah.
Okay.
So
I
basically, if
think
you're
you can go
taking,
up to 20 without having to do anything. If you go over 20, which
yeah,
you can do with certain lab sections, I think. Actually, no, I don't think you can go over. You can go over 20 if you have a bunch of lab classes and you have to take like some 1-credit classes for. It happened to, I think, freshman honors students in CS my freshman year. Is they had like their spring semester was 21 credits or something by default, and they had to get an override for it.
yeah. Matt, what classes are you thinking of taking? Are you Mackie?
I'm trying to figure out if I can fit 3 co-ops and an MS into 5 years.
Yes, just take summer classes.
Okay. Yeah, no, my plan is I have to be careful about which classes I take when, because sometimes only certain classes are offered over the summer. And if I accidentally take them over the fall, then I just can't take anything over the summer.
So are you Mackie?
Yes.
Take statics as soon as you possibly can.
Okay. Yeah. That was what I kind of got out of the prereq.
Because statics is a prereq for everything in Mackie.
Yes.
So I would say take statics in the spring.
Okay, I'm gonna
thermo
stop
over the
recording.
summer.